All right. Looks like we're all fired up here. Make sure everything here is working. Let's see. Because my my chat is not showing anything for some reason. I don't know why. Use docs menu on the menu bar. Okay, that's fine. Let's see if I can get this docs thing. Yeah, you probably have the bell notification, so yay for you for being first. Oh, here it is. Chat. Let me reload it and see. There it goes. Yeah, I don't know why I was being stupid earlier. Uh, I think I have. I think the RTC Discord showed that. Um, Honestly, I'm not really hyped for that movie just because basically, fuck Chris Pratt. I don't like him at all. Um, I don't like how he views certain things. So, you can react to it. I can, but that's not to say that I will. Um, but we're not focusing on Mario. We're focusing on a completely different platform. All right, let me let's see here. More TG16 debugging. Um, you know, would it really hurt YouTube to have some form of click to copy your live stream? Like, would it really hurt? Because now I have to go into like this YouTube channel just to make things um simple, and then it's just really fucking annoying. Okay, sorry. Just have been having a bit of a rough week. I had a contract that I was working on that didn't go well, so I'm not happy about that. So I have to go and find a better contract. So it's going to take a lot of time out. I'm going to try and do these more often. I'm going to try and find time for these more often because I've been sitting on this game for so long. I want to actually start working on it and get done with it. So, um, you haven't missed much. I'm still setting everything up. I'll be turning the screen on here momentarily. I just, it's it can take a bit. I was going to do this earlier, then I got hit with a stupid fucking class. It's just my luck. Like each and every time, I'm like, okay, I'm gonna get a stream started. I get hit with like some bullshit last minute class that this guy wants to do, and I was like, fuck. So I'm like, well, I can't do it now. So I was gonna do this like a half hour ago, and yeah, or about an hour ago. So if I seem annoyed, that's one of the reasons why, among other things. Um, Give me like 2 more seconds. I gotta find the places where I want to put this. So um yeah. Let's see. I think I'm still muted on that other place. Or maybe not. Um, you know what? Fuck it. I'll paste it here, and if they don't like it, they can suck my dick. All right. So it's like whatever. Okay. So anyway, let me minimize this out and you know, get some of this going here. So there we are. All right. So hopefully you can see all that. Um, and hopefully we're good. Oh, I guess I'll keep OBS open then. I'll just put this in the back. Okay. So here's where we left off. Let's go ahead and load. We'll just do this. Make things simpler for me. And we'll pause it. Okay, so making sure everything here is visible. All right, so what we did last time was we uh, basically we got a log, and I think I was going over what's in this log, and the more I look at it, the more I realize that BizHawk's even BizHawk's code logging is a pile of shit. Because if you look here, like right here, um, you can see BNE minus 15, and if you were new to assembly, that'd be very confusing. But what this basically is it is a branch instruction. And a branch instruction will have some sort of signed offset, meaning you can either go forward 128 or back 128 for like an 8-bit offset. A competent code logger would show the actual address that it's jumping to. Um, so so it's essentially jumping to F1D5, and you can see that that's going backwards from F1E2. So what that means is that instead of it should say it should say this. It should say F1D5 like this. But it's mildly retarded, so it doesn't. Um, so it is kind of annoying. I guess what I could do is this. If it's really bothering me, I could just do this. Hold up. Because you know what? It is bothering me. Um, we're going to do this. Hold on. Um, and I wonder if I can do overwrite. No, of course not. So I need to do this a certain way. So, and then what was it again? F1D5. So, and then just do a replace all. That's how it should look. So close. So I don't know why it's like that, but anyway. So let's take a look at a few things here, though. So we have kind of our first 10. This is obviously a loop. By the way, I recently tried to find this video I love, but I think it got deleted. Yeah, that happens. There have been videos that I loved, and I'll look through my favorites, and then I'll see that it's gone. I'm like, well, that sucks. Sometimes it's something that I'm not even too sure what it was, and I'm like, well, whatever I favorited is gone now. So, but yeah, little off topic for what we're doing here, though. So yeah. Anyway. So let's look at a few of these instructions and kind of get a general idea of what these are. So let's start from the beginning. So STA is store accumulator, and that's going to store whatever is in A here. So I guess I should do a quick recap of registers or what all this is. So this is where it's executing. This is the opcode it's executing. This is the mnemonic, the assembly instruction, and the operand if applicable. These are the values of your various registers inside the processor. So you've got the accumulator, which does most of the math. You got index registers that usually keep track of address offsets and looping and just essentially counters. I cannot remember what P is for. That is actually, if I take a look at this really quick, that might be the status register. If I had to guess, yeah. Okay, so P. So they have this in here twice because again they're the BizHawk. Whoever made this logger is a bit of an idiot. So I don't know why you would need this twice. But if you look, this is 03, and if you look at the at the bits here, you'll see that. So lowercase bits off, uppercase bits on. So value of 3 would be 00000011. And you can see that the last two here are uppercase. So essentially, this is this. This is a stack pointer that can come in handy sometimes. Um, I need to figure out how the stack how the stack works in the TG16. But I'll worry about that later. Um, and then let me see here. Cycles, we don't need to worry about that. And again, these are your status flags for the processor. So that is used for conditional branching, all that fun stuff. So that's what kind of makes processors smart. Instead of just running through a list of calculations, it determines what it should do based off these. They're very important for standard processing. So it's like your if and then and else statements and for loops and whatnot. So yeah, so very important. So that is essentially each line of instructions in a nutshell. Of course, that's just a crash course in it. I'm not going to go into major details. You'll have to look up assembly on your own if you want to learn more. But that's kind of the long and short of it. So this is storing the accumulator at this address. For the TurboGrafx-16, when it comes to CPU address space, the first 2K, hexadecimal 2K, is essentially registers. So I believe 0001 and 02 are graphics registers. So this is I should have opened up graphics registers somewhere. I may have to do that later, but let's not worry about that right now. What we do know from my memory is this is the data register. So when you write to this, it writes to whatever address it's set to. So I don't know what address it's set to because, surprise, all they have are the basic CPU registers. They don't have the memory map registers in here. They don't have the graphics registers at all. Although it'd get very cluttered if it did. But I mean, it would have been nice to see that in real time. But not the end of the world. You're going to be looking at a few more things here. So that, think of it as VRAM write, which we want. That's what we're looking for. Now, this just increments the Y counter. So that gets incremented from 54 to 55. Again, that just keeps track of things. Now, here's where here's where it gets interesting. It's going to take, and this is like an indirect read. So this is essentially, and this is 0 page, so that's why it's a little byte here. But whenever you have something like this, when like parentheses like that, it's don't take literally what's in address 03. Take what's in the address that it's pointing to, and then go and grab that. So so I think it's best to find out where it's grabbing it from, because that, I think that will help us out considerably. So so let's make a note about this. So we know that 0 page address 03 is something, right? So let's go ahead and take a look at that. So here we have tools. Now, oh, you know what? I don't know. Shit. We need to, let's reset this. Or reboot the core, because apparently we don't have soft and hard reset. That's, oh, I want to take the devs of this emulator and slap them in the fucking face. Okay, let's just reboot the core. So core is rebooted, and And let's go back to our tools here and pull up uh, the tile viewer. There we are. And we're just going to run a couple frames here. And we should start to see some magic happen here. There we go. Okay. So I think we did it like right. There we are. Okay. So here, that's your that is your background tiles that it's reading to. So we're kind of in the place where we need to be, because we want to make sure that the memory is gonna match what we were doing earlier. So let's take a look at the hex editor, and we're just going to, okay, so that's main memory. So this is 0 page, so we know that it's going to be essentially everything from here to here, basically. So except for this, obviously, that was my mistake. So all this is very quick access memory. Very important to have in 8-bit CPUs. Uses less instructions. It's quick. Uses less cycles. So this is where you want to put anything that you use often. So indirect 03. So that's going to be this here. Okay. And give me 1 second here. Excuse me. Okay, so what this shows me is that you have so this is Little Indian. So you have 3B02. That so let's make a note about that. Hope if I spelled address properly. So 03 has the value of 3B02. Okay, so that tells us that it is in memory address this to 3. Okay, and this is RAM. So for the TurboGrafx-16, it's in the second region of CPU addressing. So basically, that is so it's reading these values from RAM, and the physical address for RAM would be this minus 2000. So so the RAM address would be something along the lines of this. Hopefully you guys are learning some. So you take 2 out from there, and it's 1B02. Okay. So let's scroll down and see what shows up there. Well, this is interesting. So if we look through all this here, this all looks like potential tile data. You can kind of see a pattern there. So what this tells me is that starting from, I want to say, probably 1802, because this here, this looks like an address. 3C03, probably an address, if I had to guess. I don't know what that is yet. We could probably find out later. So let's make a quick note about this. But let's do this. Let's try something. Let's try file. So we can actually save this as a binary. This whole section of RAM, and we can kind of see essentially what it's doing. So let me see here. If we go into projects, okay, I have a bunch of crap here, so just ignore it. And we'll call it Bonk's Revenge. RAM dump. Okay. So, um, so now, and I'm just gonna kill the display here really quick, just to get some other things loaded up here. Don't want anything private popping up here for some stupid reason. So let's get Tile Molester out here really quick and take a look at it. Ba-da. Okay, let's move this. Actually, I think we're fine in terms of display. Yeah, there we go. So, um, put it like so. I gotta sneeze. Me. Okay. So let's see if we can open that up. Um, let's see here. Yeah, I know you can see my file directory, but there isn't anything too bad here. Where's my projects? Oh, there it is. Staring me right in the face. Wait, that's not it. Boop. This one. How about all files? Thank you. So I'm gonna look at a RAM dump here. So it's gonna default to NES. So let's go ahead and switch that back to like SNES. So codec, I think that is I want to say it's this one maybe. So we will. Oh, it's not gonna. It's. I might need to. Might need to do this, and that might let me. So, oops. Ah. Okay, so it's pretty obvious now. Now that we've um adjusted. So basically, so this is where it's kind of cool. We found where the decompression is going. So apparently, if we that's not what I wanted to do. We'll do this. Yeah, that's fine. And then okay, so we look at this like that, and we can see that at RAM address 1802, that's where the actual decompressed graphics are stored in RAM. So that's probably where they use the buffer to get all the tile data, and then once it's done decompressing, then it runs a loop to send it on over to VRAM, if that makes any sense. So it gets sent there first, and then it goes to VRAM. So that helps. So if we go into our so let's see here. So decompressed tile data starts at RAM address. What was it? 08. Oh, so you want to say like 1802. And so I guess the next question is what exactly is the how to put this into words? What exactly is 1800? Because you notice that there was something before it looked like it could be, I would say, some sort of offset, maybe starting VRAM address if I had to guess. So that could be useful. So let's take a look at this here. So it's 1800. Let's see here, possibly VRAM offset. So that is probably where that is. So So what's the next step? So we figured out where the decompressed data is. Now what we need to do is we need to figure out where where's pulling the compressed data, because that's what we want. We want to find out where that is. So next step would be to try and set a breakpoint and hope that BizHawk doesn't give us the finger. So disclaimer: BizHawk's debugger is a pile of shit. So this might work, this might not work. Here's to hoping for the best. So let's go ahead and reboot the core again and pull up the debugger. So this is what we're going to do. So this here, breakpoints. That's the good stuff right there. So let's try to add a breakpoint, and we're going to add a breakpoint at. We've got to do it with the with the CPU addressing in mind. So for RAM, you got to add 2000. So I'm gonna say let's do 38000. Okay, and let's see what happens when it gets written. So we're gonna add that, and now we're gonna run and see what happens. So it ran. Nothing's been written to the tile viewer yet. So that's. Let me move that over here really quick. Okay, so that's fine. So let's see if it did something stupid, or if it did something. Okay, so shit. All right, so it broke at E079, and these are what we call, if I remember correctly, these are BBS instructions. So, shit. See, that's what I was afraid was going to happen. Because, son of a fucking bitch. For some really stupid reason, I don't know why, and I was afraid this was going to happen. Oh, by the way, it shows branch of equal -14, so they can't even get that fucking right in the debugger. So for some stupid reason, whenever you break, it has really shitty brakes. It would be the best analogy. Like if you're driving a car and your brakes were bad and you couldn't stop right where you needed to stop, you would stop like several feet ahead. That's exactly what's doing here. It'll brake, but it'll brake way too far ahead. Because it looks like here it broke on E079, which would be hold up, which would be so brake at E079, which I believe would be ROM address 0079 actually. So yeah, 00, because you have to minus E000 when it is on the first page of ROM. So I mean that's cool, I guess, but the problem with that is I don't know. I don't know the address that it broke on. Let's take a look at RAM and kind of get an idea of what the hell just happened. Okay, so that's all empty. Oh, you know what? That's probably it. Okay, so let's look at a few things here. All that zeroed out, all that. So what this probably did, if I had to guess, was it probably zeroed out most of everything. So we probably broke into a initialization routine, if I had to guess. But it still kind of pisses me off that that this wait, where, where the fuck are we now? See, this is why I hate the debugger. It's such a piece of ass because we're in a completely different spot now. It's like, dude, make up your fucking mind. I feel like strangling someone at this point. Okay. So this might be a problem just because of the let's reset the core. Okay. I find it interesting that they set everything to 0, which is kind of weird. Um, at least they got the PC at E000, so that's kind of nice. Where's my breakpoint? Did it seriously reset the? Why is this set to ease? Oh my. Oh wait, it's right here. Okay, good, good, good. Okay, so that all makes sense. That's pretty. Why would it jump here? Um, some of these are really fucking weird. Oh, TA. Okay, so I'm still having to learn, uh, essentially, how some of these things work. Let's take, just a quick look at some of these things here. So basically, it sets FF, I believe, is RAM, or it's the or the registers. I want to say it is. I'd have to look it up. Next time, I've really got to pull up some resources for the TG16. But it's got some interesting things here. One of these is the break, which is, I think, this one, and then branch always to. Oh, branch always, I guess, to this, which is weird. Again, I really hate how they show branches, which is, it's like really really annoying. Can I even step? Please? Oh my. Yeah, I we may have to take a different approach with this for a couple reasons. One, uh, um, the breakpoints on this suck shit. So I mean, let's try this again. Right, and run. So the I see no right instructions anywhere close to what we just did, which which is bullshit. Let's do it again. And it's just breakpoint hit like twice, like they really don't know what the fuck they're doing. Again, I don't see. I mean, maybe. Okay, what does the PC here say? EDC8? Okay, so it's actually all the way up here. It looks like it is doing something. Didn't know you were. Sorry, I'm right now. I'm looking back at my chat. Didn't know you were still alive. I need to check my chat more often. That's my mistake. Yeah, I'm still alive. Just been busy. And I'm trying to get this one game done. It's just and I gotta do it while I have time to stream, because I've had requests before to showing how I corrupt games. So that's what I've been trying to do. This is the hardest part of it all, though. This is like the really tough part, especially when you have a debugger that is an absolute piece of fucking garbage. So this broke at EDC8. Um, so we'll or so essentially 0DC8. So that could be helpful. It is trying to do things to 07. So if we go back into 07 here, so that is 1850. So okay, that that's fine. Yeah, what I may need is I may need a better um, I may need a better debugger. But the problem is the TurboGrafx is such a like a niche system, relatively speaking, compared to like the Nintendo, the Genesis, the Super Nintendo, etc. That it's really hard to find anything worth its salt in terms of like debugging. Like again, Nintendo, Super Nintendo, they have Messen for both, and that's like a dream to use. Genesis has several different debuggers, each of them having their faults, but they're functional enough. And then you have this shit where it's like fuck, it's like I don't know what the fuck I'm doing, you know. So, um, how are we looking with okay, so we can see that it has been written to. So that's nice, I guess. Um, trying to I'm trying to think what the best course of action is going to be for this because, like I said, this the debugger for BizHawk is such trash that it's going to be really impossible to do this the standard way. What I may have to do is I may have to like do code and data logging instead, which I was trying to avoid, but um, that might work because this debugger is this debugger is absolutely just horseshit, and it's like functionally just horseshit. Just and I'm not too sure how I'm. Let me edit this. I'm gonna try something else really quick here. I want to see what happens when we write to yeah, thank you, and then run. What did it write? Okay. Um, See, that's the thing about this is, uh, yeah. What? So, God, this is annoying. You notice that it's not on a. So I think it should be on. Okay, F1AC. Yeah, yeah. So that works. But you can see that it is. It's not on like a write instruction at all. It's transferring. I think SXY is is transferring from one index register to the other, I believe. I'd have to double check that, but it's definitely not an SDA instruction or anything like that where you'd actually be writing to the memory location. So the whole debugger is unreliable. Um, I may have to come back to this. Maybe I don't know. I'm trying to think of the best way to do this. I think what we may do is, hmm, this is so much fucking bullshit. Um, Give me a moment. I'm trying to think of the best way to tackle this. Okay, let's look at the log file again, and we're gonna save this just because it was bothering me. Um, okay, so how about so if we scroll down here and this, okay, so you can see. So let's just keep walking through the code and see if there's anything here that that kind of gives us a little bit more leeway here. Um, so you can see that once we decrement x, and then x is 0, branch not equal. So now we go to f1, e4, and it looks like we pull y from the stack. Okay. So the stack moves forward when, okay, so it's kind of a backward loading stack. All right. So what we need to find is, yeah, I don't know how well this is gonna work. What are the registers at least? So okay, so FF was the registers. It's F8. That's the RAM. So okay. Um MPR4 is, so it could be these. That could be the where the graphical data is. This is always going to be 00. So 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 these two are not ROM, and then the ones after this. So it could very well be that MPR2 is code, MPR3 is code. MPR4 and 5 could be data, if I had to guess. MPR6 I'm not too sure about. Let's see here. So let's see here. Yeah, I really need a better debugger if I'm gonna pull this off. How about, okay, I'm gonna try something else here. Because what I would like to do is, okay. So I'm gonna stop looking at the debugger because it's not helping me at all. I gotta keep reminding myself not to use BizHawk's debugger because it's just a buggy piece of shit, unfortunately. So if anyone knows of a debugger that doesn't suck, by all means, like, let me know in the chat, because in order for me to kind of go through code, I need to kind of see, you know, something a little bit better here. Um, I will I do want to mention other notable, let's see here, other notable offsets. So we've got indirect 0B. So that has something, obviously. So that has nothing in it. So maybe that won't help us. So, okay. I don't know why Pop Player decided to put something there, but I'm gonna get rid of it. There we go. I gotta get rid of that recycle bin too. So what was oh, that's the offsets file, just as a heads up for whenever I do find data here. So this, I believe, is Okay. Uh, that is just incrementing the high byte in here. Wait. Oh. Oh, fuck. Oh, that, you know what? That's right. We need to, uh, there we are. Okay, so, there we go. Okay, so now that's more in line. So, okay. Now if we take a look at this. So, where was that I saw? Yeah, it's like right here. Okay, so, okay. Ink compare. Okay. Yeah, that just increments the high byte. And then we're returning from the subroutine. Okay. That does help a little bit. So whatever this was, like right here, um, that is that might help actually because that at least gives us an offset to the tile copy routine, but I don't know. Maybe it doesn't help us as. It would help us if the debugger worked, because then I could be like, okay, set a breakpoint here, you know. Um, but the debugger is terrible, so um, I might want to make a note about that though. Like if we go to here, hold up, I got an idea. So we're in the ROM address space now. I can probably find this if I know what I'm doing. 11C0. Let's see here. 11C. Okay, so I'm curious where it jumps to. Other way, that's F1, F0. So that's right there. Oh wait, I'm sorry, F1C0. I was wrong. Let me let me move this over here so I can see what I'm doing. So okay, so F1C0 is C608, right? Yeah. So before that, there's going to be there should be something before that that's going to be some sort of jump, or I mean, technically, there should have been there should be something here that would well, I don't know, maybe not. Let me try something. F1B. Yeah, I don't know where the hell that is. Because this should be a jump and this should be a JSR routine. It's like right, right. So it's going where it left off. So that doesn't make any sense. Like, where the hell are you? So it should be something. So 02 would be, jump to subroutine, but it wouldn't be jumping to 0B44. That would make any sense. Where the hell is it jumping to then? Because then it would just jump to. Because that's definitely where we are. Right here. That's definitely this here and here. But before it should be some sort of jump to subroutine instruction because that's where it's continuing from. What the hell is this? Maybe I will open up the debugger. Hold on. Can I go to um I can't remember if I can go somewhere. Can I go to F1 BD? No. I can. Oh wait, here we are. Let's try this. F1 BD. Seek 2. Wait, I didn't want to put a breakpoint. No, no, cancel. Go away. I really, really hate this debugger. Wait, what? I no, just I don't know where it took me, but I don't want to be here. That's not where I want to go. I can't. Oh my God. Um, just go somewhere. Just fucking. Okay. Let me grab something really quick here because this is starting to piss me off. Let's see here, TG-16. Um, is it? Give me a moment. This is a service manual. It's not quite what I wanted. Um, Covell. Where are you? Where is it? Here it is, I think. Here we are, opcode matrix. I don't want that visible, guys. Thank you. All right, that should be fine. There we go. Okay. All right, so since the debugger sucks, I'm gonna try and like kind of look through this at the table. All right, so 0B probably isn't it. Yeah, that's definitely not it. So that's an operand. 44 is what is BSR? Um, Stand by. Maybe that's it. Maybe it's it's like branch to subroutine. BSR. Ah, so okay, so it's that's weird, but sure. So I'm thinking that 440B that's the branch to subroutine. I don't know why you would want to do that, but let me see here. But let let's take a look. I guess it's just a different. It's just a quicker way of branching to Still really fucking weird. It's just kind of one of those things where I'm like, what? It's like, well, what the hell are you doing? Subroutines, branch. Yeah. Okay. So that's why I couldn't see it. So that is. I'm gonna have to look up branch. Oh, I guess I can turn this back on. Hold on. Let me move this here. I need to like save these like locally so I don't have to keep like searching for them. But let me there we are. Okay. Yeah, all this is interesting to say the least. I need to pull this back up so I can keep an eye on the time. Okay, so let's take a look at this here. So yeah, so it's kind of one of those things where it's like let's see. Oh, okay. That's interesting. All right. So and branch B. Okay. Program counter switch to stack. The value of the program counter is pushed. So wondering why you do a branch to a subroutine. Usually subroutines are much further away. Addressing machine code 44R, number of bytes, number of cycles, right. So okay. So it looks like let me look at this. To 0B. So plus so you take so I want to say you take let's see here. Okay, so decompressed tile. Yeah, this is weird. Decompressed tile routine starts at. So this is going to be. It'd be like at F1 B E plus. Guess that's plus 1 plus essentially 3 plus 0B. So I don't I don't feel like doing math right now. I'm just feeling tired. It's been a rough week. Yeah, so it's like I want to say it's like CC maybe, but let's I keep forgetting it's Alt 4, not Alt 3. So if we were to do like F F1 BE plus 3 plus B. Yeah, wow, I was able to do that in my head. So that subroutine branch seems like it subs over to F1 CC. It looks like, I think. So if I'm correct. So so And that kind of matches what I have here, the 11D5. So maybe. Starts at um, that is one way of checking that. So if we were to do a search, oops, maybe I need to bring that back. Okay. So if we were to do a search for F1CC, let's see what happens. That's nice. Okay. F1CC. Oh, um, that's why. Let's try this. F1CC. Really? Well, that's where it's jumping to. Can't find the text F1CC. Hmm. Don't know why. Don't know why that's not showing it, because that should have worked. Where does F1CC take us, by the way? 0F, then 20. Keep forgetting what these BBR instructions are for. Take a look at that really quick. Branch on bit reset. Huh. Circles given at the table was that should be as increased, not increases. Um, Number bytes 3. Wait, hold on. Is that the right? BBR. Yeah, so it's okay. Um, I don't get how that works. Why would it be referencing the 0 page? How the hell does that work? Hold on. Let me read this. Okay. So specify 0 page. Oh, wait. Oh, okay. So it's not okay. Okay. So it's not for the status register. It's just for flags in memory. Okay, I can see how that could be useful. Um, I don't know if it's something that I'm still wondering if I got the math on that correct. That's kind of my problem here. Is there any? That's an idea. Why don't I do that? So why don't I do a search for F1BE and see what the hell it does? I know that it has to hit this. That's not. There it is. Okay, so oh, what? Um, I guess okay. I guess it doesn't. I guess I read that wrong. But that doesn't make any sense. Let me look at that branch yet. So it's actually F1CB, not F1CC. That's stupid. And then you're going to jump to indirect 200F, which could be, which would be, which would be in zero page actually. So I don't know why they're using that, but you're going to, so there's a jump location in. Did I just close that out? Can I get it back? There we go. Okay. Um, so That's even weirder. How are we on time? Oh, what game? I really need to look at the chat more. Sorry about that. Bonk's Revenge, actually. So, um, okay. So I gotta learn more about how these work. Branch. There was the break branch. Ah, okay. So I'm gonna read this again here really quick because yeah, there's something about this where uh because it looks like you add one to the program counter, and then you push the program counter, and then you add two to the program counter, plus whatever offset this is. But yeah, they don't really make that clear, do they? Um, so because this would be the original program counter if that was, yeah, that's kind of stupid. Okay, you know what? Whatever. Fair enough. Um, so yeah, very strange. But then on top of everything else, um, go back to main memory. You're also jumping to what was it? F, I think, which would be looks like F1 CE, which would make sense, I guess. So, hold on, find. I don't want a match case, by the way. F make things easier for me here. Oh, whoops. Oh yeah. So yeah, it's right there. I kind of just did that subconsciously. So I'm wondering why they would have a jump table like that though. It's like why would you need to jump around like that? So this is where so this is essentially where the decompression transfer starts. So we've done like a whole lot of nothing. We're back at square zero. Um, yeah. So I mean, we learned a little bit, but so F1CB technically is where it should be. So I mean, that's nice. And it's actually technically 1-1. CE is and but I'm probably going to I got a weird warp in Chuman food no one's ever seen. Can't figure out how it did it. I don't know if you're asking me how that happened, but I'm not familiar with that game. I don't even know what platform that would be on. Never even heard of it. Um, so it starts at 11 CB, but it jumps to 11 yeah, 11 CE for some reason, which again doesn't make much sense to me, but that just seems like it just you could just no op that and it would do the same damn thing. B C D, yeah. So just three instructions later, doesn't make any sense. But that's what it does, which doesn't make any sense. I guess if they wanted to have a different copy routine, they could put that in memory so that it just jumps somewhere else instead, I suppose. But I'd have to look more into the code more, which again I can't really do because the debugger is a pile of horseshit. Um, so damn it, as I mentioned before, progress was made, but not much. And what we may have to do is we may have to do like code and data logging. And if worst case, um, what we can do is we can kind of get like kind of take a closer look at some like heuristics for the for the various banks and kind of get a general idea of where code is. And we could just do a code corruption, a code only corruption if this is proving to be too much, because I have the skill, to kind of find decompressed data, but if I don't have the right tools, then my skill kind of means nothing. I kind of had to do that eventually with Sonic 3D Blast, where I just didn't have really good tools, and because Genesis debugging is kind of it's not great. It was a lot better than this. So I've got to kind of think about it, but I've got stuff that I need to do now, and I gotta get ready for a few things, and then I also got to go ahead and get some other stuff done, and just I'm always busy with something. But in that case, I think next time we're going to try code and data logging and see if we can make some progress that way, and hopefully that might help. But right now we're not really getting very far with it, unfortunately. So in any case, I'm going to say that will about do it just for the time being. So um, we will go ahead and stop streaming and go from there. So see you guys later.